Welcome back, gangies. We're back to do some more LeetCode. I think today we have tomorrow, and Sunday. Yeah, I think these will be the last 3 uploads we do on this of this style. We have the daily LeetCode thing. I'm thinking today, tomorrow, and Sunday will be the last of the daily style videos. I'll still be doing LeetCode every day, I think. Who knows? I might just decide to do something different at the end, but I think we'll still be doing. I think we'll still be doing. Yeah, mine. We'll still be uploading videos regularly, but I think I'm gonna upload 1 video a week. It's just gonna be a super cut of all the videos that I'm gonna intersperse with a bunch of other nonsense. But yeah. Maybe we should wait till the end of the year. That'd be kind of cool. Either way, we'd still do it every day. But I think the distribution. Yeah, so that's what I'm thinking. Then we'll just do a super cut that releases on Sunday. And I think that would be a better outcome. So yeah, I think that's what we're gonna try and do. We'll see where the wind takes us. But yeah, we might do it for a couple weeks and then just go back to daily code. So it really depends. I think the recording part, the daily recording part, is really bothering me. Not, I feel like I'm always in the mood to do LeetCode, but not always in the. So yeah, just doing some thinking. We shall see where the wind takes us. That being said, though, I don't think we have any comments today. Oh, we actually do have a comment. Can you put lo-fi music in the background? That could be Flames. I usually play some anime nonsense. Anime is a feel strong, man, but that would actually be kind of difficult. We will be able to do this in the future. Talal Kule. Trust me, you only have to deal with this 2 more episodes, 2 more videos, because then we'll do a lot. We'll try, we'll try harder in the upcoming videos that'll be released more on a weekly basis. I think that'll be a better outcome probably than the current. But I just installed a new router, so I actually can't even access YouTube regularly. I can only access studio.youtube on the allow list, which is actually helping. So I apologize. Unfortunately, we cannot meet this request. You will only have to deal with for 2 more videos. Things will be better from here. Doggy. So yes, that's what I'm thinking. That being the case, I'm gonna have to actually suffer through today, tomorrow, Sunday. Then we can switch to the new format. It's only 3 more videos, and then yeah, that'll be pretty epic. So I'm gonna probably name this one something very dramatic. Actually, no, maybe I'll say that for Sunday. I'll name this something very dramatic, like I'm done. And it's gonna be pretty epic. But yeah, we do have to jump into combination sum. This problem is actually cooking me. Hope we can find a way around it. Yesterday I was having some trouble thinking, but fortunately I got to spend some time today working on some things that are pretty important to me. It's actually pretty dope. So we got to eat the frog first, kind of flames. So we got to get into that. So combination sum. This problem is probably going to cook me. But yesterday we were thinking of probably doing backtracking with optimization. We're pretty much given an array of distinct integers, which is candidates, or an array of distinct integers, candidates, target integer, target. Turn a list of all unique combination candidates, chosen numbers summed to target. May return the combinations any order. Same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. Same number may be chosen from candidates an unlimited number of times. Two combinations are unique. Frequency of at least one of the different. I think we have a way in mind to generate all of the candidates, all of the combinations that will equal the sum. However, I don't know if I know of a way currently distinctify combinations. Could always sort the numbers, put them into a set. Set will be the combination. Or if it, we could make a function that could distinctify them. So I think backtracking with optimization could work. Another thing that makes me think backtracking could be a good option. One, all of our candidates are positive, which is actually a really good sign. You don't have to worry about going back or going too far back. Well, it means we can actually optimize. If we had all negatives, all positives, the goal is to choose a number, check if our sum is greater, check if our current sum is greater than the target sum. If it is, we have to go back. If not, we can keep forward. This matter if we had all negative numbers. Yes, it would matter because the reason we can optimize this is because we know that our value will always be non-decreasing if we add a number to it. Since it'll be non-decreasing if we add a number to it, we can do an optimization, go backwards if we're greater than the target. If we have a potential to greatly pass our target and then pick up another number at the end of the combination or the list of numbers, then automatically become target, falls apart because then the optimization doesn't work. So I think this only works with positive numbers. Similarly, I think another reason this could be a good candidate is because our candidate's length is at max 30. This means we can guarantee a recursion depth of at max 30, which is actually pretty good, so we don't blow up the stack. So I think this could make sense. We do backtracking with optimization, negative numbers, so if the last target, we should stop. About a case where target is equal to 30 and candidate 1. So one other thing we have to keep in mind is that numbers are all distinct. I think you just go to the next one. But because we ourselves again and again. I'm pretty sure there's a not reading in a book, but I'm pretty sure there's an algorithm we can rank and unrank. Rank, unrank. backtracking problems. Pretty useful here because the iteration based version might not be effective. Hard to go backwards, forward. Pretty much a DFS. Could make sense. Let's try it anyway. I'm gonna make a function called backtrack. We'll just call it candidate, but I kind of wish we could do something else. It's gonna hide some of the things we're gonna want to pass in. Probably gonna want to be our current sum. We're also gonna want to pass in target so we know how big that is. Additionally, we're probably gonna want a way of saving permutation, or we can do that step afterwards. Yeah, we'll try and do that step afterwards. It might make the code easier to read if we do it that way. If that's the case, add it all into array of arrays called combinations. We'll set combinations, a multi-dimensional array, pass in candidates, our current sum, which is going to start at 0, our target, and combination. Print combinations, even though it's wrong to start. Does this make sense? Does this make sense? Do this do this be making sense though? Let out a fat one. Back track. Maybe I'm stuck on the unrank and rank thing. Let's try an iteration based version. Why shouldn't option over? In fact, this might be exactly what we. If our value is larger than it, when should we? What should one node deeper in the node represent? Choice we made. Choice we made. We start at 0. We select the first node as our first version, right? We're not greater than target. We recurse deeper. We select the first node again. We continually select the first node until we're greater than target. Okay, now we're greater than target. We go back, right? Can we select the next node? Select the next. do 1, 1, 1, 1, 1, 1, or greater than target, return. Once we return, use the next number, then recurse. I think this could make sense. Let's just check if current sum equals target, right? You also probably want to keep track of I want to say current array so we know what actually numbers are actually so if our current sum equals target, we'll say combinations dot put copy current R, right? Maybe that's helpful. We return. Otherwise, right, we're going to say current sum plus equal candidate sub I current R dot push candidate sub I. In fact, right, then we should say backtrack candidates sum, right, copy of the current array, right? We're just going to spread it into pass and target and combinations. Right? Before we even recurse deeper, we'll say if, in fact, we can even do it up here. Just say if current sum is greater than or greater than target, just return. Just undo what we did, right? God, we might be, oh my God, we might be beasting. Okay. It's actually looking pretty good. Now we can do the secondary portion. All these arrays, we sanctify them. Right, we're gonna return answer instead. We're gonna say for const R of combination, right? And we're also gonna have a set, new set of type string. Similarly, for the set of type string, say if set does not have RID, right? Then we're just gonna answer dot push R, and we'll do set dot add RID. Then we can add another function called R2ID, array of numbers turns a string. First thing it'll do is sort the array of numbers increasing, and they'll just return all the numbers joined by a comma. Oh my god. Okay, we might actually be different. Okay, we might actually be genetically different. Okay, I'm not gonna lie, we started frying. Started cooking a little bit. Not gonna lie, the backtracking was a big hint, and then no negative numbers. Yeah, that was pretty epic. So I think tomorrow we'll probably read the solution, but we'll definitely stop there.